Hello, teacher. Hello, students. Welcome to Grade 9 Mathematics. Over the course of the year, we will be learning about many mathematical theories, theorems, rules, and procedures. We will study equations, graphs, geometry, statistics, and vectors. Most importantly, we will learn how these topics can help to prepare us for the future. Knowledge of mathematics can help us learn how to solve problems independently and efficiently. The study of mathematics is essential to the fields of engineering, science, and economics. It is also helpful in our daily lives. In previous grades, you learned about rational numbers and their properties. In this unit, we will study irrational numbers, real numbers, exponents, and algorithms. Our lesson today is a review of rational numbers. If you are ready, students, let us begin. You may remember that a rational number is any number that can be expressed in the form A over B, where A and B are integers and B is not equal to 0. As you see here, rational numbers include integers, whole numbers, and natural numbers. The set of natural numbers is denoted by n and includes all numbers greater than or equal to 1. The set of whole numbers denoted by w includes 0 and all natural numbers. The set of integers is denoted by z and includes negative, 0, and positive numbers. The set of natural numbers is included in the set of whole numbers, which is included in the set of integers, and all of these are included in the set of rational numbers. Students, you may also recall that a factor is a number that is a divisor of another number. For example, 6 can be divided by 2 and by 3. 2 and 3 are therefore factors of 6. Conversely, 6 is a multiple of 2 and 3. A natural number with exactly 2 distinct factors, namely 1 and itself, is called a prime number. Examples of prime numbers include 11, 43, and 79. A natural number that has more than 2 factors is called a composite number. For example, 1, 2, 3, 4, 6, and 12 are all factors of 12. So 12 is a composite number. If a factor of a composite number is a prime number, it is also called a prime factor. Let us look at the factors of 45. We can factorize 45 by writing 9 times 5. 5 is a prime number. 9 can be factorized by writing 3 times 3. 3 is a prime number. Therefore, the prime factors of 45 are 3 and 5. Every composite number can be written as a product of prime numbers. This is called prime factorization. To find the prime factors, begin by expressing the number as a product of two factors where at least one of the factors is prime. Then continue to factor each resulting number until all the factors are prime numbers. Students, please find the prime factorization of 1,290. Page 4 of your textbook has a list of rules that can help you determine whether a number is divisible by 2, 3, 4, 5, and so on. You may begin, students.
Students, let's get ready. Begin. Let's get back to our lesson.
Hello again, students. I am sure you did not find the question to be too difficult. 1,290 is divisible by 2, so that is our first prime factor. The next composite number is divisible by 5. The next composite number is divisible by 3. The last number, 43, is a prime number. Our prime factors, then, are 2, 3, 5, and 43. Great work, students. If a number is a factor of 2 or more natural numbers, it is called a common factor. Numbers may have more than one common factor, and the largest of these is called the greatest common factor, or GCF. Because large numbers can have many factors, a quick way to find the greatest common factor is to use the prime factorization method. Let us look at an example. The prime factorization of 160 and 180 gives us these results. We use the product of the common prime factors. 2 and 5 are common factors. We take the lowest common exponential power, which is 2 squared. Our GCF is therefore 2 squared times 5, or 20. Students, earlier we learned about multiples. Recall that 6 and 12 are both multiples of 2 and 3. The least common multiple of 2 and 3 is 6. When we compare large numbers, it is quicker to use prime factorization to find the LCM. The LCM is the product of each of the prime factors to the greatest number of times it appears in the prime factorization. Using our previous example, we would use 2 to the power of 5 times 3 squared times 5 to find our LCM. The LCM is 1,440. Students, please use prime factorization to find the greatest common factor and least common multiple of 64 and 48. Show all of your work.
Students, let's get ready. Begin. Let's get back to our lesson.
Hello, students. Your prime factorization should look like this. The greatest common factor is therefore 2 to the power of 4, or 16. The least common multiple is 2 to the power of 6 times 3, or 192. If you had any problems with these exercises, please ask teacher to look over your work after the lesson. Today, we have reviewed rational numbers, natural numbers, whole numbers, and integers. We have discussed the definitions of prime and composite numbers, as well as factors and multiples. We have learned how to use prime factorization to find the greatest common factor and least common multiple of a set of numbers. In our next lesson, we will learn more about rational numbers. Until next time, thank you, teacher. Thank you, students.